Good morning, dear students. Now we are going to take one more topic that is known as corrosion. The question arises how corrosion is a spontaneous process. First of all, let us discuss about the word corrosion. As you know, corrosion is the oxidation of metal like iron, zinc, copper, etc. due to the atmospheric oxygen, water, or by any other gases, even by chemical. Now in this topic we are going to discuss about the corrosion of iron. One more important thing, please remember that corrosion is always an electrochemical process. How it is an electrochemical process? Now let's see with some diagram. Now you can see I have written some reactions in the corrosion of iron. Let's see this diagram. For example, it is a pure iron metal. It is a pure iron metal. Let's take, I have made two spot number 1 and spot number 2. What happening at the spot number 1? Spot number 1 acts as an anode in which oxidation takes place. So if it is acts as an anode, what is going to happen? Iron metal is present, it will going to be oxidized. Then from 0, its oxidation number is 0, will changes into F2 plus with the release of electrons. For balancing, I have written here 4, 2 and 2. For 1 iron, it will produce 2 electron. For 2 iron, it will produce 4 electron. It is an oxidation reaction, therefore it will also have an oxidation electrode, or we can say it as an reduction electrode. So reduction electrode for iron 2 plus from iron is minus 0.44 volt. Now what is going to happen to the electrons? Now electrons from anode is going to be transferred to the another spot in the same iron metal, and the another spot that I marked as a 2 will act as a cathode. Now in the cathode the reduction will occur. Here the 4 electrons which comes from the anode, these 4 electrons which comes from the anode will shift to another point that is known as cathode. What is going to happen in the cathode? These 4 electrons in presence of the atmospheric oxygen and H plus ion will change into the water. Now the question arises, from where this H plus ion occur? Had we put some acid? No, we don't have put any acid. So from where this H plus ion comes, I will let you later on. Okay, dear student. So from where it will come, I will let you later on. Now see, the electrode potential is also written for this reaction, that is plus 1.23 volt. Now what will be the overall reaction? The electrons will cancel out each other because these are in the opposite to each other. Now what is left? 2Fe, 2Fe, O2, O2, then 4H plus, 4H plus. From the another side of the arrow, that means from reactant side, it is 2Fe2 plus, 2Fe2 plus, plus 2 moles of water is produced. So if I make this overall reaction, then it is a redox reaction. In the redox reaction, you know the standard potential of the cell can be calculated as standard reduction potential minus reduction potential at the oxidation. That is, reduction is plus 1.23 volt minus 0.44 volt, right? And the total becomes plus 1.67 volt. After subtraction, we get this value, right? So because electrode potential is coming in the positive terms, so we can say corrosion is an electrochemical process. Always remember, corrosion is an electrochemical process. Now the second point is that it is also an spontaneous. This reaction is spontaneous. That means it will occur by itself because the electrode potential is positive. So two things are important: electrochemical process and spontaneous. Now what happens to the Fe2 plus which produces at anode? This Fe2 plus is less stable, therefore it will change into the Fe3 plus. See the reaction. Here the Fe2 plus which produced at the anode changes into Fe3 plus in the form of Fe2O3 by reacting with the H2O and oxygen which is present in the atmosphere. Also H2O can also be obtained from cathode. Either it is liquid form from the air in the form of moisture or from the cathode. So when it will obtain Fe2 plus obtain H2O and half O2, it will change into Fe2O3 plus 4H plus ion for balancing. It is for balancing. This Fe2O3 plus 3 oxidation of iron dot XH2O This is of brown color. This thing is of brown color and it will shed from the iron. आयरन से नीचे झड़ जाएगा एंड इट इज़ कॉल्ड रस्ट. ये रस्ट का फॉर्मूला है जो आयरन से सेपरेट हो जाता है. तो रस्ट कहाँ पे बना एक्चुअली? इट फॉर्म्स एट द कैथोड और एनोड. यस, इट फॉर्म्स एट द एनोड when Fe2 plus changes into Fe3 plus. Dear student, remember these reactions also. These are important for your exam. Now one more thing. In the earlier I have asked you from where this H plus has been obtained. Is there any acid? No, there is no acid. From where this H plus is obtained? It is believed. Some of the scientists believes that H plus which is obtained at the cathode is from H2CO3, which is also known as carbonic acid. This carbonic acid comes from due to the combination of CO2 and H2 which is present in the air. So we can conclude that H plus comes from H2CO3. Now this is the chemistry of the corrosion of iron. Now we will discuss some of the points which can prevent corrosion. So first point, as we know, painting, greasing is the common thing. Another example is covering the surface with some other chemicals. For example, bisphenol. Remember this word bisphenol, star mark it because it is very important. In one of the board examination 2-3 years it was being asked which chemical you can use to prevent corrosion in the iron. So your name should be bisphenol, right? Now the another important word related to the prevention of corrosion is sacrificial electrode. What are sacrificial electrodes? Sacrificial electrodes are another reactive metals which are more reactive than iron, like magnesium, zinc. On the surface of iron, we have to apply these sacrificial electrode on the surface of iron which oxidize itself. That means magnesium and zinc will oxidize because these are at the outer layer of the iron, and they will prevent the oxidation of the iron instead of iron. That means zinc and magnesium will oxidize themselves and prevent oxidation of iron. Therefore the iron will not get any rusting. Thank you very much.